In this class, we'll be looking at how to add hexadecimals. Adding hexadecimals is very much similar to the same way we add the base 10 numbers or the binary numbers. However, we have to be very careful because base 16 numbers can be somewhat complex because at some point we replace them with letters. Now, when we look at this section, we can see that A in hexadecimal represents 10, B represents 11, C 12, D 13, E 14, F 15. Now this key is very important in our computation of hexadecimals. So it helps us to keep a track and so that we don't lose focus of what we're doing, right? So but then for this exercise, I will first do the logic of adding in normal base 10 and then see how this logic actually works. And so we can build the logic again. And then implement it in hexadecimal. So now an example is adding 19 base 10 to 29 base 10, right? So in this case, what we do is we basically pick them up block by block, right? So when we add, we have 9 plus 9, which is basically 18. 18 is bigger than base 10. So what we do here is we know that 9 plus 9 is 18. And since 18 is bigger than 10, or it's equal or bigger than 10, so what we do here is we have to minus it from the base. The base is 10, and so we take a minus, and then we have 8. Now, because we are minusing it to reduce the number to be less than base 10, basically what we do is how many times did we have to minus 10? We had to minus it 1 time, and then we will take this one. Basically, we take this one, and then we will take it to the next part here. And so here we have another 1. So basically, you have 1 here. And so you have, and then we'll take the 8, we'll bring it here, which is basically saying 8 here. And then the next block is 1 plus 1 plus 2, which is 4. And then we have 48 base 10. So this idea is what we will do when we try to add. So basically, we move to the example, the hexadecimal example. Now, in the hexadecimal example, we will take a few cases. And so here we have an example of 1AB plus F2C, right? So basically, we will take this, it's all in base 16, and then we will do an addition. Now, we will take it block by block so that we don't mix things up. So the first block is B plus C. Now, for B plus C, this is equivalent to saying, so if we make reference to this block, B is equal to 11 plus C, which is equal to 12, and this gives you 23. Now, 23 is bigger than 16, so what we do here is we have to minus from 16, which is basically giving us 7. Now, we take 7, and we transplant 7 here, and because we have already done, we had to reduce 23 1 time to 7, it took us 1 time, basically. This 1 time, basically. So then we take 1 and put it here. And then we will go to the next block, right? So in the next block, we have 1 plus A, which is 10, plus 2, which gives us 14. Now, 14 is not more than 16. It's not equal to or more than 16. So this is very good. then we basically have to take 14 and put it here. But, you know, in base 16, 14 is equal to E. And so we bring E here. And then we go to the final case, which is basically this block. And so in this block, we're looking at 1 plus F, which is basically 15. And this is giving you 16. Now, 16 is equal to the base, which is 16. And so what this means is we take 16 minus 16, which gives us 0. So here, and then how many times did we have to reduce it? This is 1 times. So basically what we do here is we take the 0 and then we put it here. And then we take the 1 and then we bring it here. And basically, since there's nothing on this side, we drop 1. And then we have 16. So our answer is 1, 0, E, 7, 16. So this is our final answer. And this is the way to add hexadecimals. Thank you. Looking forward to the next class.